Welcome, our viewers, to our great channel, MotoMouths Uganda. We talk about car systems, road systems, traffic systems, name it. We shall be talking about it here. And as usual, we urge you to subscribe, like, and comment on our videos. Give us your views on what you want to see here, what you want us to discuss, and we shall keep trying our best to give you what you need. Today we have an interesting topic about cooling systems in engines. And we have our resident engineer who is going to guide us through some of these complex things and make them more, palatable for some of our simple minds that are only interested in seeing the car moving. So, good afternoon, Engineer Ivan Chibuka. Welcome to the channel as always. We look forward to learning a lot from you.
Yes, good morning, Ivan. Incidentally, where I am, it is morning. It is not even yet daylight. It is 6:30. I'm in Detroit, Michigan. So I'm about 8 hours behind you. Yeah, I'm glad to see you wearing our Mwiri t-shirt. I'm also wearing the Mwiri jumper. It's very cold here. Currently it's -11. It has been snowing for the last 2 days, mostly at night. So it's looking very white out there. Yes, it's actually cold. You can see I'm wearing the jumper, but also inside I'm wearing a long sleeve t-shirt. I'm also wearing another short sleeved white shirt. And I'm inside the house, which is heated. So you can imagine what is outside. Yeah, and incidentally,
it's a good day I guess it's a good day to discuss cooling systems.
exactly, that's where I was coming. So it's a good day to discuss cooling systems. As usual, I have a small presentation which I'm going to share here. It's going to be a bit wordy today, and it will be several slides. Yeah, can you see it?
Yes, I can see it. Automotive engine cooling systems.
Yes, thank you very much. So we shall get straight to business. Forgive my voice, I'll be coughing a little bit. I'm just recovering from a cough, which I got the moment I got here about 6 days ago. I'm recovering and my voice may not be the normal one. It may not be the best, but I'm going to try. So the function of the automotive cooling system is to cool the internal combustion engine. Because most of the chemical energy in the fuel that is consumed by internal combustion engine is converted into heat, these engines become pretty hot very quickly. Control of the engine temperature by way of cooling is therefore critical to avoid its self-destruction, because if it's not controlled, the engine will get destroyed within a few minutes because it gets really hot. And I have to remind you, out of the chemical energy that you get out of fuel, for petrol cars, the most efficient ones are just approaching 30%. Diesel cars are in the late 30, the most efficient one in the late 30s in terms of that is percent in terms of efficiency. So you can imagine most of the energy from the fuel, like the bulk of it, 60, 50+% is being wasted as heat, you can imagine. So there's going to be a lot of heat inside any internal combustion engine. So it has to be controlled. Automotive engine cooling systems are designed exactly with this priority, the one of cooling, in mind. So we have majorly two systems. There is the air-cooled, which is not so common these days, and then the more common one is the water-cooled one. Let's begin with the air-cooled one. Not very common, like I said, but most of us recognize it in you remember the Volkswagen Beetle, the old one, the Chikere. That one had that type. I think there were some small baby, we used to call them baby Fiat. I used to see them when I was a child in the late 80s and 90s, but now they are no longer common. And I think Porsche, some Porsche, those sports cars, I think the early ones, some of them had air-cooled system. So those systems are not common anymore, so we shall not dwell a lot on them, but I will just say these are air-cooled engines with multi-cylinders, usually, not a single cylinder. Remember the ones of motorbikes and lawnmowers are also air-cooled, but their system is simpler because they are usually single cylinder. But for internal combustion engines in cars, they are usually multi-cylinder. So they especially must have some form of fan cooling and ducting to make sure all cylinders are cooled evenly. The cylinders and cylinder heads are finned. They have fins on them to be able to discharge the heat that they generate. Outer areas such as near the exhaust ports on the cylinders have bigger fins, of course, because they produce more heat. Fan-blown air is directed by a metal cowling. A metal cowling is like a housing, so it stays close to the finned areas. A thermostatically controlled flap will control airflow. So when the engine is warming up, the flap will be closed to restrict the movement of the air. So the cooling will not be that much because ideally you want the engine temperature to, when it is cold, you want it to raise to the most efficient temperature and then keep it there. So once the temperature rises, when the engine reaches its normal operating temperature, the flap opens and allows the air to flow over the engine. That is like a few minutes after the engine has started running from cold. The engine fan is in air-cooled system. The cooling fan is a large device and is driven from the engine belt. If you remember that Chikere, that when you opened the back, because the engine used to be at the back, you'd see the fan, you'd see the belts. So this belt must not be allowed to slip or break because if it does, damage is definitely going to occur very quickly. Car heating is not easy to arrange with an air-cooled engine. You can imagine you have to build piping around the hot pipes so that cool air is pulled over those pipes and the fins and then goes into the cabin inside the vehicle to warm you up. So it's not easy to arrange it, but air is passed through this device where it is warm. It can then be used for demisting and heating with the aid of an electric motor and fan. In Uganda, we don't use the heating option a lot because temperatures are usually ideal for us to use the vehicle without even heating. Sometimes what we use is air conditioning, which is cooling the air in the cabin. We rarely use it to warm ourselves, except when we drive in mountainous areas in very early mornings. I don't know if you use the heating side of things, Alan.
I see people put it on sometimes when the car has been parked for long and the windscreen is foggy.
When you don't have air conditioning, there is a combination of the heated air that you can use to demist the windows. We used to use that a lot in the UK. We used to have cars that did not have air conditioning, and it would be every morning you always needed to demist the windows. But we don't use that a lot in Uganda. Anyway, we now move to water-cooled systems, which are more common. The main parts are a water jacket around the engine, and then a water pump, a thermostat, a radiator, and a cooling fan. Those are the major parts. There are smaller components, which I may not mention here, but these are the major parts of a water-cooled system. You can see it's quite different from the air-cooled one. The water-cooled engines work on the principle of surrounding the hot areas inside the engine with a jacket. The water takes on heat from the engine, and as it saturates through the radiator, because it is pumped, we shall come to that in a moment, the water, after it has gained the heat from the inside of the engine, it flows through a radiator, which is what you see at the front of the car, and it exchanges that heat to the atmosphere. The heat concentration around the top of the engine means the water pump is needed to ensure proper saturation. That's why you now see some engines with sometimes the aluminum engines, sometimes they are steel, the blocks are steel, but the cylinder heads are aluminum, because usually the top of the engine, that's where most of the heating activity happens. So they get very hot. So normally the top of the engine gets hotter than the rest of the engine. So the water pump saturates water through the radiator when the thermostat is open. The thermostat is not open all the time, especially when the engine is still cold or cool. It only opens up when the engine has been heated to a certain temperature. The water saturates on around the engine when the thermostat is closed. So when you have just started the engine, the water will start, the pump will pump the water around the jacket, but the water will not be going into the radiator. So there will be no cooling effect. At that point, the engine temperature will be rising. So coolant from the engine water jacket passes through a hose to the radiator on top once the engine is warmed up and the thermostat opens, then through thin pipes called the radiator matrix. That is what you see in the radiator, those fins, you see those small pipes you see going up and down the radiator. Those are the thin pipes, and they have fins on them to increase the rate at which they lose heat. So usually they tend to be on the lower tank, although nowadays there are some tanks which most of the radiators have a lower tank and an upper tank. So because the water is flowing from the bottom up, but these days there are radiators where the water is flowing sideways, not upwards. Many water passages between the top and bottom tanks of the radiator are used to increase the surface area. I've just discussed that. And fins further increase the surface area to make the radiator even more efficient. A cooling fan assists airflow. The heat from the coolant passes to the pipes and the fins, and then to the air as it is blown by a fan over the fins. I think you can see a series of heat exchanges going on. So this is an image of a typical water-cooled system layout. Most of us are conversant with this because this is the scene most of the time that you are greeted with when you open the front of the car, the bonnet. You have in front here, this is the air conditioning equivalent of a radiator for cooling the refrigerant for air conditioning, but behind it, you have the radiator. So usually the cooling system for the AC will be placed in front of the cooling system for the car. But usually when the vehicle is tending towards overheating, when the computer senses that the engine is about to overheat, it will even suspend air conditioning, because air conditioning reduces on the efficiency of the radiator to cool the engine. So anyway, I won't dwell so much here, but you can see the heater matrix, you can see the heater tank, the pressure cap, you can even see the thermostat and the various pipes. So very quickly, because we don't have a lot of time, I want to say that a thermostat is a temperature-controlled valve. Its purpose is to allow coolant to heat up more quickly and then to be kept at a constant temperature. There is a lot of misconception where when a vehicle tends to overheat, people remove the coolant. That is bad. It is wrong. If the thermostat is bad, replace it with a good one. If that does not fix the problem, please find out what the real problem is if it is not the thermostat. It is lazy troubleshooting to remove a thermostat because you are going to create problems because the engine will now be overcooled and it will wear out faster. the engine will continue running, but the engine will get old much faster, and it also burn a lot of fuel because the computer will always try to be increasing the temperature. It will be dishing out more fuel. So it will be dishing out more fuel. So it costs you when you don't do the right troubleshooting for overcooling or overheating condition. Simply removing a thermostat is not good. Even in countries which are hotter than Uganda, like in the Middle East, they have thermostats in the vehicle. They don't remove the thermostats. Anyway, modern engines run more efficiently when at the correct operating temperature. The action of the thermostat is such as to prevent water circulation from the engine to the radiator until a set temperature is reached. The people who design the cars or the engines know exactly what they are doing. Stop removing or altering components on this engine. You are doing more harm than good. So when the valve opens, there is a full circuit for the coolant, and a good cooling action occurs because of the full flow through the radiator. And a constant action of the thermostat ensures that the engine temperature remains at a constant level. The thermostat type used on almost all modern engine is a wax capsule type. So when it warms up, it expands and pushes some components so that the water can pass. Although there are some electronic ones, but again, they use wax. So electronic ones are where a computer can command the thermostat to open even before the engine has warmed to say 80 degrees. Even at 40, the computer can command by hitting that wax and opening the thermostat. For some reason, there are some scenarios where the engine computer may desire to open the thermostat electrically. So that's on newer cars. Many of the newer cars, especially the European ones from the mid-2000s, they have electronic thermostats. So if the thermostat is faulty, ensure that the correct type for the engine is fitted, as some work at different temperatures. So even if you replace a good thermostat, make sure it is the right one for the car. The water pump is driven by, there is also the water pump. We'll discuss the thermostat for water-cooled engines, but also, like I mentioned earlier, one of the major components is the water pump. The water pump is driven by a V-belt or multi-V-belt from the crankshaft pulley or by the cam belt. The pump is a simple impeller type and is usually fitted at the front of the engine, where you find the belts. So it assists with the thermal siphon action of the cooling system, forcing water around the engine block and radiator. Thermal siphon action, Alan, you know this thing of when you put water in a kettle and you see waves of the water rising from the bottom where the heating element is, rising towards the top. Yeah, so that is the so-called thermal siphon action. Yeah, so let's move on to the cooling fan. The engine fan maintains the flow of air through the radiator, and it is mounted on the water pump pulley on the older systems, and also even some current models, especially the diesels, because their engines are usually longitudinal in position in the engine bay. So most cooling fans are now electric because the engines are placed transversally, and also because it is more efficient to cool. That if you have a mechanical cooling fan, it is always robbing power away from the engine, even when it is not desired. But the electric one will only run when it is needed. So it is more efficient. So that's why you see more cooling fans working electrically these days. The forward motion of the car also helps the air movement through the radiator. That's why normally you not have the cooling fans running when you're on the highway, but you have them kick on when you are stuck in traffic. So cooling systems are generally sealed, but on most vehicles today, they are sealed or semi-sealed, which allows them to operate at pressures as high as 100 pascals above atmospheric. And this helps in raising the boiling point of the coolant which goes even beyond 126 degrees centigrade. Remember, water normally at ambient pressure boils at 100 degrees centigrade. So closing the system or sealing it allows the system to work at a higher temperature. The system can therefore operate at a higher temperature and therefore with greater efficiency. The pressure buildup is made possible by the radiator pressure cap, which contains a pressure valve which opens at a set pressure when it is hot, and a vacuum valve which opens at a set vacuum to allow water back into the radiator, into the cooling system. On a semi-sealed system, air is pushed out to the atmosphere through the pressure valve as the coolant expands. Air is then drawn back into the radiator through the vacuum valve as the coolant cools and contracts. A sealed system has an expansion tank into which coolant is forced as it expands. This is normally the tank that you see on top of the engine, somewhere in the engine bay. And so when the engine cools, coolant can flow from the tank back to the cooling system. So this is an image again of the cooling system, just to remind you of the features, because next I'm going to be discussing cabin heating, which will be the last part of this presentation. Heat from the engine can be used to increase the temperature of the cabin interior, like I mentioned earlier. This is achieved by use of a heat exchanger, often called the heating matrix. It's like a radiator, but smaller, but it's positioned inside the cabin of the vehicle. So due to the action of the thermostat in the engine cooling system, the water temperature remains nearly constant. The air being passed over the heater matrix is therefore heated to a set level. A source of hot water is now available for heating the vehicle in the interior. And some form of control, of course, is required over how much heat is going to be taken into the cabin. The method used on most modern vehicles is blending. This is a control flap that determines how much of the air being passed into the vehicle is directed over the heater matrix. Some systems use a valve to control the hot coolant flow into the heater matrix. And by a suitable arrangement of flaps, it is possible to direct air to control the temperature to selected areas of the vehicle interior. In general, basic systems allow warm air to be adjusted between the inside of the windscreen and the driver/passenger footwell. Fresh cool air outlets with the directional nozzles are also fitted. And the final thing is, which is the availability on many vehicles, is the choice between fresh or saturated air. The primary reason for this is to decrease the time taken to demist or defrost the vehicle windows, and simply to heat the car interior more quickly and to a higher temperature. The other reason is that, for example, in heavy congested traffic, you may want to close to stop venting air from outside, because the outside air may not be very clean. I often do that. I often put my cooling system in the saturation mode. Yeah, so finally we've come to the end of our presentation. Thank you for your interest and sticking through to the end. I know sometimes some of these technical topics can get a bit boring for some of you, but we need to discuss them because these are some of the biggest problems that bring you to garages, and they cost you plenty money. So I'll stop the sharing here, and I'll respond to any questions or comments that you have.
Thank you so much for that detailed outline on how cooling systems work and which types are there, how each one of them works. And yeah, I liked your parting shot that these things may be complicated, but we need to listen to them because they end us costing when the car comes into the garage and we are not sure what exactly has happened. So my comment would also be along those same lines. What would a car owner have to look out for to avoid their car heating up, or the engine, that is the engine heating up? What should they do? Sometimes I see cars just parked by the roadside with the bonnet open, Others slow down their journeys. I have also seen some buses where they remove the front grille, I think to let in more air. But I have also seen cases of buses catching fire and even some cars. So, what precautions should someone take? Because I think the problem usually comes when the dashboard starts lighting up, and many of us don't know what those lights mean.
Oh, by the time the light on the dashboard comes on, many
Mm.
times it's quite late. The computer is trying to show you there is something wrong, but ideally you should have caught this earlier, because when you have a temperature gauge, has CH, C for cold, H for hot, it usually should sit in the middle, and it will even indicate normal. And as it gravitates towards H, it will reach an area with the red on it. So the moment it starts lifting from the middle, excuse me, that's a bad. That's already it's a warning that something is going on. The problem is many of you drivers just keep driving on the road, enjoying, chatting, talking on the phone, yapping, buying chicken. You are not watching what they call the vitals. A lot of those warning lights on the instrument cluster are very important. They indicate vital things, temperature. Some these days you even have an indication of the outside temperature, like where I am right now in Detroit, it's -11. So even if it has not snowed, there is a danger of what they call black ice. You have water which pooled in an area overnight because the temperatures went negative. That water froze. It becomes like a skiing rink. You get. Yeah, so that gauge warns you when you are inside the car. For you are inside the car, the system we've just talked about is warming you, so you don't really feel it is cold outside. But that warning on the dashboard is to warn you that the conditions outside are icy. There are other warning systems, like for the alternator, when you see the battery light come on, when the engine is running, that is a bad thing. It means the alternator is not charging. The engine may continue running, but it will not be for very long. You will not get very far. So the thing is warning you to stop and take remedial action. When the alternator doesn't work, you start draining the battery. There are other warning lights like the fuel gauge. I know a lot of you pay attention to that, at least, because most of you are aware when you run out of fuel, you are going to get stuck. So some of you tend to pay attention to that one, but please learn to pay attention to the temperature one as well. I normally, in my driving, I've learned to scan those gauges every few minutes, because you may scan it like 5 minutes ago and an overheating incident happens pretty quickly. You can destroy an engine very, very quickly when it overheats, especially when you are in mountainous areas. So what to look out for, things like that, is very important. First of all, before you drive, check your cooling system. Everybody is taught this during when they are attending driving school. In fact, in the UK, part of the driving test, the practical driving test, before you even get behind the steering, you do the theory on the computer and then you go for the practical. Start of the driving test, the examiner could challenge you to show him or her how you examine the cooling system, how you check the battery, can you change a tire in an emergency. I see a lot of people, when they get flat tires in Kampala, they stop by the road. And these days, people don't even get off the road. They remain in the middle of the road, put on hazard lights, and call someone on a boda to come and change a tire. People, grown up, how did you get your driving license if you cannot change a tire? Every driver should be able to do this basic thing. Changing tires, checking coolant. A lot of you are getting expensive repairs because of this kind of laziness. I would want to call it laziness, because if you got your driving license, if you went to the right driving school, these are the things they will teach you. Check oil, check coolant levels, check for leaks of both oil and coolant, check the battery, things like that. The tires, those are basic things, wipers. So even the cooling system is part of these daily checks that you should be doing. Even if you drove the car to your workplace in the morning, it's not a bad idea to check it again in the evening. After all, it will save you a lot of headache if you realize there is a leakage, rather than getting on the road and getting stuck there. I don't know if you are together. Then you mentioned something about buses catching fire. Buses are normally they normally have diesel engines. They would not catch fire because of engine overheating. I doubt the temperatures in the engine, because of the water cooling, never rise beyond 150, even in the worst case scenario. By the time an engine gets to 130, 140, it has already seized. Yeah? It will have stopped running. It will be destroyed. So those are quite low temperatures to catch fire. And diesel does not catch fire at normal pressure. It is possible for petrol, very, very possible. But diesel, so those buses, when they catch fire, it is probably friction elsewhere on the engine, maybe on the belts or some other components. The fire is probably not from the cooling system or the failure of the cooling system. So it's probably other parts of maybe the belts or other metallic parts which are moving, they get out of alignment and they rub against each other and start a fire. Something like that. Sometimes it is cargo. Sometimes bus users carry dangerous cargo. So you mentioned also buses removing the front grille. Yeah, it may increase the cooling efficiency a little bit, but by the time you get to that vehicle is not right. You should be going to the garage. You should be going to the garage. By the time you are doing all those things, there is something wrong with your cooling system. You should be fixing it. Alan, are you there? It appears as if I'm not sure if your internet is good. Yeah, I can hear you are back. Yes, I see you now. You had frozen. We have about 5. Oh, your modem was switching.
Yes.
Okay, sorry about that. Now we have about 5 minutes. Is there something that I have not answered from the things you asked?
Not really. I think you have.
Oh,
maybe
some
you
people
could say
something about
that coolant, because sometimes when people go to buy that
exactly
liquid
that
from
is what I was about to touch on. The so-called coolant, water is the coolant, or it's what they used to use, water on its own. It's what they used to use in the past. Now they started using adding additives. One, to limit corrosion in these countries where they have these very big temperature differences. The internal piping of the cooling system can get corroded very easily because their water has funny chemistry and the temperatures. And also the water can freeze. Water by itself freezes. I'm telling you right now, we are at minus 12 right now. I'm seeing the temperature here. In Michigan, where I am, it is minus 12. So if pure water in the cooling system will have frozen. So when you go to drive, you will have ice. So the pump will try, it may even break the pump because the pump will be driven when there is ice. So to avoid the coolant freezing, they started putting additives that lower the freezing point so that even at minus 12, so they lower the freezing point to maybe minus 30. So when you go out to drive at minus 12, the coolant is still liquid. And also they put additives also to prevent damage to some other components. That's the main reason. And also to increase the boiling point a little and also lower the freezing point for the water a bit. That is the main reason for the coolant. Using water by itself may not be so bad because people take it now as if it is a crime to use water on its own. No, it can work, but it is better for you to use the coolant because of the other advantages that I've mentioned about. You avoid the clogging, the piping of the cooling system. You avoid in countries which get cold like this one, you avoid damage to the cooling to the pump or to the water pump and the engine itself generally. So yeah, please use coolant as recommended, but it is not the end of the world if the engine is not running on coolant. Yes. Yeah, I think we've run out of time. Thank you very much for your time. I think we shall come back again to discuss another topic. Okay. So you are muted, so I'm not hearing what you're saying. You have muted your mic. Okay, have a good day.